he was human. It was cubes. And he says, I think it takes at least k. So from this sort of 27, 3 cubed, 60, 2 cubes, what the exponent is. I showed that. Cubes. 2 cubes power. This wasn't a counterexample. Gauss finally proved. A little bit later, what's really going on here is the fundamental theorem of algebra, right? Except for real polynomials. In the 18th century, they were just talking about real polynomials, in which case the best you could hope for is breaking them in the second and first degree pieces. But it wasn't clear you could, and he did. At least this wasn't a counterexample. Gauss finally proves the result that you can do it. Okay, so let's see. So now, back to the question. Did Euler ever get anything wrong? Let me show you that, yes, he was human. He did. Let me show you something he got wrong. He proved that the sum of 2 cubes can't be a cube. And the sum of 2 fourth powers can't be a fourth power. Now, if you remember what, in the 90s, there was all this hoopla about Fermat's last theorem. Fermat said the sum of 2 powers can't be one of the same kind if the exponent is 3 or 4 or 5 or 6 or anything higher. And Euler showed that Fermat was right about cubes. 2 cubes can add up to be a cube. So if I wanted to, I could say this. For whole numbers, x, y, and z, x cubed plus y cubed can never be z cubed. And Euler showed that. And he showed that x to the 4th plus y to the 4th can never be z to the 4th, can never be a 4th power. But that's as far as Euler could go. Fermat said it was going to be true no matter what the exponent is there, as long as it's above 2. Euler said, I think that's a hard problem to do it in general. And it took 200 years more. You know, when Euler says it's a hard problem, don't even think about trying to solve it. You know. All right, so anyway, that Euler did. But then Euler knew that the sum of 3 cubes can be a cube. Two cubes aren't enough, but 3 cubes can add up to a cube, and there's an example. I don't know if you know this, but if you take 3 cubed plus 4 cubed plus 5 cubed, you get 27, 3 cubed, 64, 125. You add them up, you get 216, and bingo, that's 6 cubed. So 3 cubes can be a cube, but not 2. So from this sort of elementary evidence, Euler puts forth a conjecture. And he says, I think it takes at least kth powers to add up to be a kth power. So if you want to get cubes, you need at least 3 cubes. If you want to get a 4th power, you need at least 4 4th powers to get a 4th power, 5 5th powers to get a 5th power, 6 6 powers to get a 6th power, and so on. It was a nice conjecture, but it was wrong. Euler was wrong. Now, he didn't claim he could prove it. I will say that. He didn't claim he could prove it, but he thought it was true. And he was human because he was wrong. But like anything when Euler got wrong, it was pretty hard to show he was wrong. Nobody could find an example until 1966, when Lander and Parkin found 4 5th powers that add up to a 5th power. Euler said you need 5 5ths to be a 5th. No, these 4, 27 to the 5th plus 84 to the 5th plus 110 to the 5th plus 135 to the 5th is 144 to the 5th. And that's the smallest example. Those are 11-digit numbers if you expand those. So Euler was wrong. You don't need 5 5ths to be a 5th. 4 could. But then what about 4ths? That was still open now. You know, do you need 4 4ths to be a 4th, or could 3 4ths add up to be a 4th? That wasn't solved for 20 more years until Noam Elkies from Harvard, who's still up there going strong, showed that that was false too. And he found those 4th powers, 2,600,000. Yeah, that's right. He's a New Yorker, right? And you know, he's a legend in the mathematical world. But anyway, he showed that 2,682,440 to the 4th plus a few other cousins like that add up to be 20,615, 673,000 to the 4th, and those are 30-digit numbers. So Euler was wrong, but for him to have seen he was wrong, he would have been roaming among the 30-digit numbers, and even Euler would have trouble with that. So yeah, he wasn't perfect, but you know, when he made a blunder, it was subtle, shall we say. I'm not sure that's been proved, actually. That's a good question. Yeah, the question is, can I find 4 4th powers that add up to a 4th power? 5 5ths. Can we guarantee that's always true? Maybe somebody knows the answer. I'm not sure if that's been found at all. It's a good question. No, I don't think they've proved that yet either. Yeah. But what they did prove was, you know, Fermat's theorem. 2 of them aren't going to work. It's not. Yeah. Right. Because two cubes can't be a cube. Yeah. Right. This is this is very heavy-duty stuff. But anyway, Euler did get some things wrong. Now, the Swiss government issued this piece of money back in the 80s, the 10-franc note, which has on it, as you can see, our hero, Euler, as it should. You know, in the U.S., who do they put on money? Politicians. But in Switzerland, great thinkers like Euler. And it was Condorcet who said, all celebrated mathematicians now alive are his disciples. There is no one who is not guided and sustained by the genius of Euler. Euler was quite a great guy, but he is unfortunately not well enough known in the general public. Right? If you were to go out on the street here on 2nd Avenue and ask a passerby, have you ever heard of Brahms? Da, 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 da. Yeah, musician, let's say. You ever heard of Gauguin? Painter, right? I saw Moon and Sixpence, I remember that. Robert Louis Stevenson, he was a writer. Euler, I don't know. They wouldn't know him, right? He's probably not known. And what's really tragic is those people aren't Euler's peers. You know, in the realm of music, he's not the Brahms, he's the Bach of music, of mathematics. He's not the Gauguin of art, he's the Rembrandt. And he's not the Robert Louis Stevenson of letters, he's Shakespeare. And the fact that people don't know the Shakespeare of mathematics is really tragic. So as you leave here tonight, what I want you to do is go back and talk him up. You know, tell your co-workers about this guy. You know, the bumper stickers on the car. You know, fan club, something like that. I don't know. You know, I mean, Euler does show up in Will Shortz's crossword puzzle because it has 3 vowels. You know, Swiss mathematician, 5 letters, Euler, 3 vowels. Yeah. But, yeah, Gauss seems to be somewhat better known, although in the general public, I'm not so sure even of that. You know, the general public might have trouble identifying any mathematician, I'm not sure.
I think you're exactly. You know, Euler, I mean, you compare him to Riemann or Gauss, Newton, anyone. Euler doesn't come anywhere. He didn't any new discipline. I'm just saying the facts.
Them's fighting words.
Finally, he standardized a lot of math. I agree with you. He was a great mathematician, but he was not a genius. Gauss invented so many things, you know, in math.
Well,
look at differential geometry, look at what Riemann did, number theory.
Well, I will. This is the kind of argument you can't win, and I will concede that those were great.
Thomas Gray, something like that.
No. I will disagree with that. Euler invents analytic number theory. That's Euler. Graph theory. That's a whole branch that is now.
He solved the Königsberg problem, but he did not invent graph theory.
Okay, but all right. Euler characteristic. Yeah, I mean, all of these things are quite great, and you know, Riemann certainly did amazing things. But how much of Riemann was built upon Euler's foundation? Quite a lot.
Brilliant mathematician died young usually. This guy
he lived too long. Yeah. Right, that was his mistake. Yeah. Sometimes dying young is a great career move, right? Yeah.
Maybe you just think about it. It's worth remembering that perhaps most famously Riemann did invent the Riemann zeta function, but it's already used by Euler 100 years before. It's named after Riemann now because he gave a more
Riemann
regular method.
is one of the fathers of complex function theory. I mean, if you just look at the work,
The person on the street doesn't know about Riemann either.
Einstein, you know, paper, the first thing he says is, mentions is Riemann's name. You know,
they used to tell a joke about my thesis advisor that you got very tough letters of recommendation, and if you were writing a letter of recommendation for Riemann, it would say, Riemann is a very good mathematician, but not nearly so good as Gauss.
There are differences. Let me just say, Gauss, and I hope everybody's heard of him too, because he's used to be on the German money. You know, so there you go, mathematicians on money. Gauss's collected works are quite limited in volumes. You know, 9 volumes. That's it. He didn't write as much as Euler. Euler wrote so much, and they had different styles. Euler's style was to be very expository, he would start writing his math. He'd say, now, here's what I'm trying to do. And he'd explain it. He'd say, oh, I tried this, and that didn't work. And then I tried this, and that didn't work. And then finally I tried this. And so you get, 20 pages of sort of background. And it's very fascinating if you want to see how a great mind works. Gauss was the school that sort of prevails now in mathematics. You only put in the basic steps, and you skip a few every once in a while. You say, the reader can see, and then you jump 3 steps, and the reader can't see what's going on. So one of these is a very terse, style, and the other is very rich. And people criticize Gauss for that. They said, you don't show us what you're thinking. You don't show us how you did this. You're like the fox that walks through the sand and drags his tail behind him and erases his tracks. I don't know how you did this. And Gauss responded, yes, but the builders of the great cathedrals don't leave up the scaffolding. That's how they built those cathedrals, but you take it down and you leave the beautiful cathedral. And Gauss would only leave the great theorem behind. Yeah?
I was just on the getting the wrong thing. Wasn't there I'm just trying to remember, isn't there something about orthogonal Latin squares where you thought something was true about 2 and 6, so maybe it was...
That's exactly right, yeah.
I don't remember what.
You got it exactly right, yeah. An orthogonal Latin square is an array, a matrix of numbers, which we won't even go into, but whether they all existed was the question. And Euler knew that the 2 by 2 did not. He believed the 6 by 6 did not. And he thought every 4 numbers thereafter did not. And he tried to prove it. He wrote a 100-page paper, but he couldn't even prove the 6 by 6 did not. Then he made this conjecture, and in 1910, somebody finally proved the 6 by 6 didn't. And then in 1980, they proved that all the others do. So when Euler thought all of these kinds of things didn't exist, again, he had misstepped. He also had proofs that didn't work. That he was working before a lot of the modern rigor entered mathematics. So he tried to prove the fundamental theorem of algebra, and he stumbled. And Gauss, to his credit, fixed it. So Gauss came along and said, no, Euler made a mistake, and he was right. So, Euler did. But, I'm putting him on my Mount Rushmore of mathematicians, even if not everyone in this room is going to agree with that.
In that whole case, we're kind of interested in, or not just kind of, but majorly interested in the notion of creative process, innovation, and originality, and process of thinking. You mentioned that Euler's character was that of humility.
Yes.
But did he have this type of thing that we've seen in mathematicians, this kind of like, I hate to use these kind of camp terms, but like idiots up on a problem. Was there something missing? Was there an Aspergian element to it? Did he have, was one form of brilliance at the
Right, which, is a stereotype, and for sometimes a good reason of some great mathematicians, that they are missing something. Newton, right, if you know anything about Newton, was an extremely misanthropic character. He would have been a tough dinner companion. He was jealous of his reputation. He got into spats with Flamsteed, with Boyle, with Leibniz, with everybody, Euler seems not to have that problem. The story is, he's friendly, he talks to his neighbors, he was a gardener, he had grandchildren that he loved and played with while he was doing his math, on the other hand. By all accounts, he was a regular Joe, and that is not always the case with some of these hyper geniuses.
Well, one of the questions is from a lay point of view again, can one see any applications, like in Gauss, you can see, the Gaussometer or whatever, are there any lay applications? Do we see Euler in everyday life from this? I know you mentioned these incredible processes of mathematical thought and discoveries, but is Euler a fact of our existence in terms of computers and things?
Well, I would cite that quotation. Everyone is his disciple. So anything that is using mathematics probably is using something that Euler touched. And that's just in the sense in which mathematics can inform other disciplines. But he explicitly gave us the mechanics in which calculus is playing a role. And
Standardized quite a lot of math, so that other people could use it. He standardized
yeah,
math so
right.
easily.
Yeah, and functions are what analysis is about. Well, that's his idea. And he said, here's the functions you want. He standardized the sine and the cosine and the arctangent and these are the functions everyone's going to use. And after he does it, everybody uses them. They're in the toolkit. So, in a foundational way, he's everywhere. And if math, is around us everywhere, then so is Euler, I think. Yeah.
Were there any mathematicians that he was influenced by?
Oh yes, Newton, Leibniz, the Bernoulli, you know, his teacher, and Leibniz, he read Euclid, Archimedes, people like that. I was going to answer the question about his family. Did he have mathematical children like Bach had musical children? One. He had one. Remember, only 5 of the kids lived to adulthood, and one of them was Johann Albrecht Euler. And he does some mathematics. He's at St. Petersburg. He writes some papers, and he wins the Paris Prize. The Paris Academy would give this prize for the best solution to a challenge problem. Euler won it 12 times or something in his life, and it actually was quite lucrative. You could make a living winning this prize, but a problem would be issued, and all the mathematicians in the world would send in their solutions, and